Hey, what's up everybody? Welcome back to another 3D Hangouts. My name is Noah Ruiz. I am a designer here at Adafruit, and joining me every week is my brother Pedro.
What's going on, everybody? I'm Pedro Ruiz, Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics to make inspirational projects for you folks. We haven't lost it, yay. Thank you guys so much for joining us. We're gonna jump into the show right away. We got a lot of stuff to cover. We're back from 2 weeks of no 3D Hangouts. We've been quite busy with Learn Guides, and we'd love to share them with you. Let's kick off this show with this week's coupon code. It's Thumbstick. There it is. It's Thumbstick. This will work with everything in the Adafruit shop except for gift certificates and those Adabot subscriptions. However, everything else is fair game. So check out Thumbstick at checkout. You just type it in the code, and there we go. So we're going to jump in to last week's and the week before's this month's projects is what we're going to look at, the stuff that we were working on. So I'm going to jump in and say hello to everyone in the chat room. Thank you guys for joining us today. We are live streaming. It is Wednesday, 11 a.m. here in the Eastern area. We're hanging out in the Discord chat room as well. So if you want to hang out with us after the show or anytime, we are hanging out here in the Discord. Howdy, howdy. Like I said, howdy. Okay, we're just checking the streams. We're streaming on all the networks, so we got to make sure all of it is accounted for. So hello YouTube, hello Facebook, hello Twitch, hello LinkedIn. We meet again. That was an evil laugh. All right, well, I have a Learn Guide of the USB crank. This is the first one we're going to take a look at. So this was a journey. The original was to just make the crank piece, which is a printed hinge. And then the last time we streamed was on June 6th or 5th or something like that. And we had the crank going, but we didn't have anything working yet. It wasn't wired up to anything. So this Learn Guide shows you how to wire up a Rotary Encoder to the ItsyBitsy. That's a little microcontroller, it costs about $12. It's got 2 megabytes of flash, or maybe 8 megabytes. It's got some megabytes of flash, so you can store all sorts of assets on it, and it works really, really great with the CircuitPython libraries. So check it out. There's a Learn Guide there. I just want to do a demo. So I got this guy set up. It is plugged in through USB because you need USB. It is a USB device. The case is a 3D printed 2/2 setup. And before I take this guy out, this is the hinge, right? I'm going to set up my little demo here. So I have a MakeCode arcade demo that's going to turn this into a kind of a gamepad. So let's take a look at our screen here. And I need to load up my this guy here, my Adabot head. So I got that. Open up a new tab. Microsoft's MakeCode Arcade makes it really easy to kind of come up with these type of demos. So I got a little Adabot here. And what we'll do now is this is the simulator. So what's cool about MakeCode Arcade is that it has a simulator that lets you play the games without any hardware. So what I've done is I've basically made 2 keys to trigger. So I'm going to crank this up and start playing this game here. So this is a good example of using the Rotary Encoder as a input device to simulate some HID keys. So key controls, space bars, macros as well. So it's really easy to add multiple key commands in the code. So this is a open source project. The code is available right now. It's been available for a while. And this is just a nice little demo of Adabot in Microsoft's MakeCode. I also have a link to this MakeCode Arcade, so you can take a look at the code blocks and see exactly how this is running. And then if I want to stop, I'll hit that button there. So you actually have 3 buttons that you can play with. Left, right, and then this button here, which stops Mr. Little Adabot there. Or maybe it misses Adabot. So there you go, that's my demo. Very cool. So obviously you can program this to do anything, volume control, changing channels, scrolling through the web, that sort of stuff. So hopefully that demo worked. I don't know if it did. Did it work?
Yes, it did.
Excellent. I don't know if it was in focus and stuff because the way we have this tunnel vision going on, so that's what we have going on. Heading back over to the Learn Guide, I'll just quickly walk through some of the parts. You really just need the ItsyBitsy and the Rotary Encoder. I use this silicone wire. It's got 10 in the bundle, so it makes it really nice to have a one cable as opposed to individual wires coming out. When we look at the circuit diagram, you can get a really good idea of how to wire this. It goes into a couple of the GPIO pins on the side here of the ItsyBitsy. To power it, micro USB. Here's the software part. So it walks you through installing CircuitPython. It's as easy as going to circuitpython.org, selecting the board, and downloading. But I already have that link here for you, so you don't have to do that. So you can just click on that and download the latest version of CircuitPython. It just needs two libraries. It needs the NeoPixel library and the Adafruit HID library. So you just get those two. And here is the code. This is available on GitHub, so you can make a pull request if you want to add to it, or if you have any issues, you can submit those as well. Yeah, it's very well commented as well. This was written by Lamar, Lady Ada herself, so check it out. It's very well commented, and you can adjust the code right here for the right here is where you check in the Rotary Encoder if it went up or down. This is where you can change it. I have a link to all of the key codes, so you can find out exactly what key code is what. It's pretty, it's written pretty nicely. So if you just read it out, dot volume decrement and volume increment, this is turning up the volume. So that's what's assigned to these, to the Rotary Encoder by default. And then this one right here, if the last button, which is the button switch that's on the encoder itself, that one is using the key code space for spacebar. Yeah, and again, all the key codes are available up here in the Learn to Docs, or is it down here? Yeah, down here it gives you an idea of where you want to change the code and a list of all the key codes in the Read the Docs document. So check those out. Yeah, so depending on how you want to control whatever application, you will want to come in here and modify the code. There you go. Skipping on over to 3D printing, it's 3 parts. We have the hinges as a standalone part. I've also dual extruded it, which is fancy. Don't need to do that. That's just a one part, one model that has 3 individual pieces that will print in place. So it's got a nice tolerance that's loose enough to work, I think, on all the printers. If you have any issues with it, let me know on Discord, and we'll see what we can do. Here are some slice settings that I used as a recommendation using Cura on Ultimaker 3. So there's that. And then here's some things about our GitHub repo with all of our parts and stuff. Wiring it up, we just walk through it pretty easy. I'm using the ground on the bottom pad here of the ItsyBitsy. It's always nice to have an extra ground, especially on the bottom of the board there. And just walking through wiring it up. For assembly, no screws are required for this, so it's got this handy little snap fit kind of feature where it clips the board into place, and then the Rotary Encoder has a little kind of ring that it gets mounted to. Rotary Encoders come with knobs and the appropriate hardware, so the little hex washer and nut get added there, and then you can add your crank if you 3D print it or not. So there you go. The box has like a dedicated spot for the crank to house it, and it kind of has like this little nub that pinches it so that it clicks and holds it in place, which is pretty nice. Snap fit features for the win. So again, we'll take a look at it. Hopefully this won't mess up any of my stuff. Let's see what it does. I think it might. I'm afraid to see. Yeah, it's just gonna go do. But we could go ahead and open up
audio cue to make sure that everything's working.
Yeah, right. There you go. We can go into the Moo editor and just change the code real quick. Let me do that. So I'll go back to screen cap and come over here, make that bigger. So where I want to change, I already have it commented here. Oh, this is the wrong code. Whoops. It will show up as the CircuitPy drive. So I'll just load up my thing. It says it's already open. All right. Scroll down over here, and I'm going to change this back to do the volume. So I'll just comment out these 2 codes like that. So hit save, open up my terminal, my serial, and it seems to be working okay. So there we go. That's what happens in the in the loop. It's saying whenever it reads it, it prints out in the terminal whether it's whether it's a positive value or a negative value. You can see here it's doing that. So there you go. My volume is now changing. Super cool. So you can change this really easily. And here's the kind of locking thing I was talking about. So now it won't fall out. So your handle is now in there. Very sweet design. Again, shout outs to the guys at Playdate. This was a really fun hinge to design and create. I wouldn't have thought about it myself, so shout out to them. Very cool. Coupon code is still thumbstick. So there we go.
Quick question from the YouTube chat.
Please.
I Love Doom is asking, is it the same library for the micro keys as the other HIDs?
No, so there is an additional library. When we released the original media dial project, the special media keys were not written yet. So these would be play, pause, next. Any of these keys up here, are like the media keys. Those are the special ones. And those are in a sub-module of the HID library, if that makes sense. So if you click on that link to see the key codes, you will see exactly what you need, what the keys look like for the media stuff, for all the media keys. So I'll open that right now because you got me thinking about it. Good question. So if you go to Learn the Docs, this one walks through all the basic stuff, F keys, and then all the numerical keys, keypads, things like that. And then as you get down to this piece, we also have mouse control, so you can do mouse stuff. I haven't played with that too much yet, so I don't know too much about it, but most of the stuff is here. It's called Adafruit's HID.consumer controls. It's used by multimedia keyboards and remotes.
Awesome. Please post that in the chat.
This link? Absolutely. Yeah. And all the chats?
All the chats. And then Thomas Vayak is saying that it printed lovely on the Ender 3 Pro.
Awesome. That's good, because they have different slice settings and different extrusion widths and E-steps and all that sort of stuff. So it's really nice when it actually works.
And then Kirby has some ideas on some cool games or applications for it, like a music device that speeds up as you crank the beat.
That's a good idea. Kirby's coming out with the good ideas. Eject, fast forward, mute, play, pause, record. All these are here. I didn't even know there was a record button. That's interesting. And those are the volume, decrement, and increment. Also, we have gamepad. Shout out to Dan Halbert. He pretty much wrote all this. To emulate a generic gamepad control. You know, gamepads, the ones you actually plug in, they have very, very different special things. They're not just playing out one key. They are doing different things. So this is what we support right now, pressing buttons and that sort of stuff.
So cool.
Unexplored area for myself, but it's all there in the docs, which is really cool. So I'd love to see some examples of that. Very cool.
Oh, sorry, Thomas, it's Veach, like beach with a V.
Veach.
I gotta remember that.
Okay. Well, that was the USB crank device. It's quite fun. And cranky.
Yeah. And then one more idea, it could be like the old style music box that a monkey would crank, and then Blinka pops out.
Oh, yes. That would be cool. Yeah.
All right, cool.
Man, we need to do that. We need to do a Blinka.
I know, that sounds like a PT project, huh? Blink in a box. Didn't we? No, I think Dano did one already, where it pops up.
Now we do need a spring. Or maybe not, maybe it's an actuator. Maybe it's a spray can and it blows it up.
Yeah, big thanks to Dan H for implementing all the consumer control HIDs as Mike Brella, and Bill Binko in the Discord is saying that, yep, they are separate USB device. It's weird.
They are, what is separate?
That's where the XAC support lives.
XAC, huh? Interesting.
So cool. All right, let's go ahead and move on to the next project.
All right, next project. Here we go. I'm going to load it up here.
I don't know what it is, actually. What is the next project?
It's going to be the snap-fit case for the PyGamer.
All right.
So we were showing this off a little bit. It's a snap-fit case for the PyGamer. No screws required, no support material required. It's just a little 2-piece enclosure. It actually a 3-piece enclosure. It has a little bezel piece that you super glue on top. That's going to help it keep the display from coming out, as the adhesive might come off here and there, but so far it hasn't happened. But it looks really cool with this bezel on top.
Yeah, shout out to using these really nice translucent materials from Filamentum. It's the ice blue color.
Yeah, that's right. Ice blue color is really nice.
And I think the only tip on this is just using like 4 layers to for the top and bottom.
That's right.
So you get that translucency. Shine through. Look at all that lovely slick by Flip Progress. So
Yeah.
awesome.
It's really nice. Couple
So
folks
this
who
was
printed it out.
yeah, it looks
That's
amazing
great.
in any color actually.
Yeah. All right, so let's take a look at the demo that we have in MakeCode. So go ahead and turn it on. Right, you're used to the PyBadge.
I know. I'm looking, and it's like the complete opposite way for the
left
switch.
is right and right is left. All right, cool. So this is a riff on John Park's DVD bouncing DVD demo. So I wanted to recreate that demo. Shout out to John Park. He has a MakeCode series
Giant
called,
playlist.
yeah, MakeCode Minute. And in one of them, I remember him talking about creating a simple bouncing DVD logo. So it's super easy to do this inside of MakeCode Arcade. So I won't go through the code and show you how to do it. Definitely check out John Park's MakeCode Minute. It shows exactly how to do it in under a minute, which is great. So when I got that running, I thought it'd be really cool to have the Adafruit logo bounce around. So I got that going. If you tilt it this way, you can see the colors of it a little bit better, like this.
Nope.
Yeah, you see how that color is there? It's not actually white. So that was the first thing. Hold it like that so I can focus on it. So that was the first thing to do. Get a custom sprite. And how do you get custom sprites? Well, John Park, again, has a learn guide on how to polish MakeCode games. There's this thing called the PXT Asset Tool. It's on GitHub. It's a free project. And you basically drag and drop PNG files, and it'll convert that into all the little ASCII characters that you can paste into the JavaScript tab of your MakeCode project. So you can create image assets much better this way. I wouldn't have been able to do it without that asset tool. So there, that's the tip there. The next thing I wanted to do was, it would be really cool if I had another sprite on the screen. So the second thing was to add a sprite. So to separate the Adafruit logo from the Adafruit text. Hit the B button, there you go. And then I was like, well, now that I have those two sprites, it's super easy to attach controls to a sprite. So now I'm able to control the Adafruit text, going left and right, up and down, and diagonal.
Continue.
What is
Continue. It's just this thing probably needs to be moved. Continue.
Oh, okay, yeah, sure. And so those are two features, or those are two like code blocks, right? The next interaction I wanted was, well, you can easily do some things when two sprites overlap. So whenever these two sprites are overlapping, I am changing the background color. So that's really easy to do. And the next thing I want to do is actually use some controls. It'd be cool if I hit the A button and turned this text into a Blinka. So I was able to do that. Then really easy. It's almost really good to whack them up. Come up, go back down. You can slice in half right there.
Okay. Yep, just increasing. Yep, increasing staticness.
I have no idea. The battery's all charged. I don't have any radio stuff happening.
Yeah, it's just getting worse.
What? You can hear it, right?
Oh, it's overpowering all of our audio.
What? Okay, well, we're gonna mute that for a second. Hey, what's up everybody? Welcome back to another 3D Hangout. Hi. I still hear the static. Hello.
Should be good.
Okay, well,
Okay,
it's
good now.
just never, you can never fix the audio stuff. It's just a forever thing. So that's the MakeCode demo that I have set up. It's also got some interesting effects. So whenever I change between the sprites, you can tell the screen to shake. It's called the camera shake. And you could also apply effects. So I have this disintegration effect happening whenever I change and switch between the different sprites. Okay, So that is the demo. You can check it out. It's on MakeCode Arcade. You can simulate it in the browser, or upload it to any of the arcade boards or any hardware that's supported for MakeCode Arcade. Very cool. All right. Hello, 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 hello. I think the static went away, huh? At least for a brief second, right? Hello, hello, hello. Hey, what's up?
Still sounds good, but again, this is a lag, so
yeah, there's like a minute delay.
I won't know until a minute passes by.
Yeah, well, we can kind of hear ourselves. Hey, what's up, everybody? Pedro?
Should be good.
I think so. All right, well, we'll move on. So yeah, that's the demo. You can check it out and see all the code blocks that I used to put it together, and it's really just a accumulation of John Park's MakeCode minutes. I also forgot to say that the neopixels are also changing. Just with a single light block, I can say whenever the sprites overlap, go ahead and change my background color. Maybe to, well, not my background color is changing, but also my neopixels are changing. So I can have those match or not. It's hard to tell the colors though, I think. There's purple, then when it overlaps, it turns to a blue.
You can kind of see it.
Yeah. I turned the autofocus off, so.
It's pretty cool.
Yeah, pretty neat. So that's the two, so that is the demo. And we have a learn guide walks you through the assembly, all the parts. Not much of assembly other than super glue. Star Bond is what we used here. I linked to it in the guide. It's a really nice super glue that has like a fine tip. You can get it from Amazon. It's really nice. It has a nice work time, so you can reposition your parts if you need to, and then it doesn't create too much haze if you apply some airflow on it while it's fuming out. Yeah. Sweet, so that's that project. The next one we're going to look at is, I think, the PyBadge.
Yeah, the PyBadge.
Yeah. Oh, real quick, the PyGamer, we have a learn guide for that. We actually had to send it to Lamar. We only had one build of it, so it's with Lamar. So we can't show it right now. But it is a learn guide that we released a week ago. This week, we released this one. This is the PyBadge gamepad. So these are a series of buttons and a gamepad, a thumbstick for the PyBadge.
Sorry, I'm trying to keep tabs on everything over here. But yeah, this is an update to the previous PyBadge case that I've seen everybody printing on. I wanted to make some updates because after your conference is over, actually, let me get rid of this guy there. After your conference, this makes a really good gaming little handheld device, much like the PyGamer, although it's like half the size or a little bit smaller than it. Definitely half the width of it, especially when you're using the low-cost version that doesn't have any headers or any of the connectors on the back. Like that, you can see the difference between them. It does make a sizable difference when you're pocketing this and on the go. So what we added here was more comfortable buttons, so a thumb pad on here instead of getting all those indents. Because let's be honest, after you start playing the NES games on there, you really get into the game and you are going to get indents all over your fingers. So I wanted to make sure that your playing sessions were nice and comfortable, so I printed these in NinjaFlex. This is the 85A, so it has the rubber like elastic feel on them. It also has like nice little sparkles on it. It's always nice. And what's cool about this is diagonal buttons work. So MakeCode does support having diagonal input. So all it's doing is just pushing the up and the left or right button, or down and left or right button, but it works very lovely. And the buttons, of course, you can print them in any colors. It'll work with PLA as well. And then what we're showing on here is No Friendo, which Lamar ported over. Spent quite a while on this, so definitely check it out. It runs really well. The nice little menu system on there. You can also save and load games, which, if you ever played any ROMs, you definitely need that, because otherwise you're gonna start all over again. And last minute addition, because when we're working on these videos and projects, we always have to freeze the project at a certain point, meaning we can't, we don't want to go in there and do any more geometry edits, because it means we're gonna have to change the whole video and guide and all that, because everything is running at the same time. So what didn't make it into the guide and video was this little addition that I added here. All it is like a volume controller. So what it does is just switches between the speaker that we added on there and the buzzer speaker, which is built in. You kind of hear how low it is, but if I switch it on, you hear just how loud the oval speaker that we have on there is, which made it quite annoying when we were out in public or driving around. I always wanted to play, but I couldn't because of how loud the speaker was, and I didn't want to just unplug it.
Yeah.
So this was a nice little alternative. And I did upload the files to Thingiverse, and I did add a page because the guide went out like 2 days early before the video did. So you can go back down there into the circuit diagram page, which we'll take a look at. I added how to install that little slide switch. All it is just additional geometry that's butted up right against the standoff there. And we do have the slide switch geometry as different parts. So if you want to just plop this into any of your 3D printing projects,
you have
super
that
fast.
And the thing itself, the component itself with the 3 legs.
Yeah, component and
nice
the geometry
switch
for that.
Yeah,
so,
we use the switch quite a bit different projects. So
yeah, kind of difficult to see here, but you can kind of see in this level select for Mega Man the diagonal action happening right over here. Let's see that. Can you kind of see it? Yeah. Yeah, it's kind of tough to see, but it does a really good job. And let's see if I could pick what's like a difficult level to show just how the button mashing is really accurate with hitting down the buttons.
That's one of the challenging things to do with 3D printing your own button actuators is getting them to not stick.
Yeah.
Because the Z and the layers, when they rub up each other, they tend to create some friction.
Yeah, so these are small enough so you don't have any extra geometry on there that you don't need, keeping everything nice and small, nice and slim. I had this carrying around all over when we were in vacation, and I sometimes forgot it was in my pocket because of how small it was, and these don't raise up too much. So nice little pocketable handheld NES emulator. So if you jump into the learning guide.
Yep.
Yeah, we're supposed to play it loud.
Yeah.
Says Michael.
Sweet. You also added you exposed the back so that we can add feathers. So Brent, who's on the Adafruit IO team, was like, hey, I kind of need the back here so they can
you can.
Wi-Fi.
I have one of those printed out here. You can see what that looks like. So I don't have the top on it, but you can kind of imagine what that would look like with that on there. And then here is the header exposed. Yeah, like you were saying, Brent is working on a guide on adding the ESP32. So you can get some Wi-Fi on the back of the board here. Get some data transmission between PyBadges, so that would be super awesome. So I sent that over. And where were we at in the guide?
It's just the
homepage.
Overview. Yeah. So this one walks you through the stuff you need. We're using the bigger, longer cabled mini oval speaker, and that's not the short wire one.
Yeah, that's only so that we can have enough slack for the wire so we can attach the slide switch.
Right. Also, the LC version does not have the Pico connector on it, so you do have to solder to it, and that's another reason why you want to get this version.
I mean, if you want something super slim, yeah, go with the LC, but if you're going to need all those additional connections or you don't want to solder the speaker to the back of it, go with the non-LC version.
All right. This is the LC version, I think? Or?
Yeah, super simple diagram here. It's just where the speakers and the batteries all connect into. Pretty much just showing this so you can see where the ground goes in if you want to solder it on to the LC version. Nice little blurb here on why we added the slide switch and how that actually connects up and how to manage do the wire management, how to route those around so it reaches the bottom right corner of your case there, so you can press fit the little slide switch on there.
Yeah, that's good. Yeah, we're just breaking the looks like the voltage wire.
Yeah.
So that's the way it's wired.
Yep. So it's just the PyBadge is just PyBadge is just reading or thinking it's being disconnected and switching it over to the buzzer speaker, which I had totally forgot that it was even on there.
Yeah. Cool.
So moving on to the code, we are using the Nofrendo to the NES emulator for Arcada. You can check out the full guide on that. This is just a simple rundown of how easy it is to drag the UF2 over once you load up your USB drive.
Yeah, it's really great. You don't have to worry about installing 12 Arduino libraries.
Oh my god, yeah.
You just download that one UF2 file and bring it in there. And then you can create a NES directory and then drop in some ROMs there. The Learn Guide also has some homebrew ROMs that are linked in the guide, so you can have stuff right
Definitely
away.
check out. And I think yesterday it was, Isaac released a awesome guide on hacking your NES ROM. So one of the examples was updating burger time, making a veggie patty.
Burger. Eco-friendly.
Yeah. Another cool thing about the Nofrendo is that the file system here, you can navigate directories.
Yep.
So you can go up and down directories. You can store, have like different subdirectories of ROMs. Like categorize them or something like that.
Seems like it has a good error handler. If something's not right, it'll tell you. If it doesn't find ROMs, it'll tell you.
Yeah.
It's pretty nice. So check it out.
It is awesome. It is my favorite little handheld. Moving on to 3D printing.
Using the powder-coated bed, PEI bed, on the Prusa to get this cool sandblasted look, I think it would be called. The textured surface is really interesting. So you can get that effect with the powder-coated PEI bed that we have. And we've got the Fusion files available to download as well as the STLs. Here are our Prusa slicer settings over here.
Yeah, this works on the Inventor as well. And the only trick here is just printing two at the same time so that the heat zone around the nozzle doesn't stay in one place. It sort of moves over and doesn't let these little tiny parts melt.
Nice. And here's the print speed, 30 millimeters a second.
That's the key. That's the two key things to remember when doing NinjaFlex: 30 millimeters a second and no retraction. Again, this is for the 85A, which is the more softer, more elastic.
Original NinjaFlex.
Yeah, the Cheetah Flex, they're the 95A materials should print at about 60 millimeters a second, and you can leave on retraction for those, but it is going to be a lot more stiffer.
Yeah,
more stiffer, it'll be more sleek, so it doesn't have any of the soft, like grippy feel, and it won't be elastic either.
Right.
But this will work with ABS or PLA. So any material you have around, you want to test this with. It should work, all the sizes. I didn't have to do any funky horizontal compensation for any of these, so
cool.
Should be good to go. And then Bill was asking how we got the translucency on the case, if we were having the layers go in the same direction, I think is what he's asking. No, they're crossing.
They're crossing,
yeah. It's
just because there's what, 3 layers?
It's about 4 layers.
For me, it's like 3, I think.
Yeah, so you can edit
3 or 4,
that.
yeah. Maybe it's 4.
And you did this with the top and the bottom? You just added like 1 for the top, 2 for the bottom?
No, I just left it. There's not more, it's just solid.
Yeah, I just did 2 on each. 2 for the top, 2 for the bottom.
Okay.
It was about 4. And so since we're still on the 3D printing page, you can take a look at the way that this is stacked on top of each other. So there's like 4 different pieces, right? 1, 2, 3, 4. So first we print out this. So it's kind of like acrylic, except that you have control over the height of each of the components or the housings for the thumb pad and the A and B buttons, and then the bezel that is glued on top. Pretty easy to line these up. Just look at where the entrances are for these, or the cutouts are for these. And we're using the same star bond. It's like the medium time to glue these. And awesome tip from Stuff with Kirby was saying that have a little desktop fan around so you don't get any of the hazing around where the glue spots for this is.
Yeah, or I tend to leave it on a table and then come back and there's haze on the freaking table.
I have seen that, yeah.
So
I elevate it too.
Yeah,
I just used one of these guys and elevated it.
Yeah. Or use it to help with their hands. We have those in the shop.
Yeah.
Like $7 or something.
A couple tips there for that.
Yeah. Cool. All right, next page is the assembly.
Something for this guy. It's pretty easy, except if you're using the LC model, in which case you're pretty much just trimming the the wires on the speakers to fit. I just show you there how to hook those up. And as we were saying, yeah, definitely third helping hands will help to keep these elevated and make sure stuff's not moving around.
Yep.
The speaker, the oval speakers that we carry have 2 sticky components on the back and in the front. To avoid any leads touching, we're going to use the fabric, what I call the front side. And there's a little sticky protective film thing that you just remove and line up with the little outline that's on there, stick that on. For the Lipo battery, we're just using sticky tack. Just made a nice little small amount on the board and just stick the 350 milliamp hour battery that we're with the short cable that's being attached to that. Take a look at how the buttons are assembled here. We're actually using M2 screws to hold the top of the button and a little washer that's on the bottom, the base of the button, which is actually actuating the button underneath that. So we'll need 3M2 by, I think it's 5mm long screws to hold those in place.
Okay.
See how that is. And oh, one last thing I forgot. For gluing all of this, a little clamp will definitely help, especially if you're using the powder-coated bed, because there are it's like a rough edge.
Oh, yeah.
You definitely want to make sure that it's making contact and not just floating on top of your parts.
Yeah.
Continuing on, here's how you can see the how the screws and the washers are attached to the buttons. Pretty simple explanatory there, you can read that. And then the reset button, a lot more easier to add that on. Yeah, it just plops right in. It has a little bigger base so it doesn't fly through the little cutout there. You just laser it on top.
Sweet.
Using the M3 screws to hold everything together, because when you're button mashing, those can pull the top of the case off. So you needed screws for that.
Sweet.
That's pretty much it.
Excellent.
It's easily my favorite handheld. A lot more smaller than the Raspberry Pi game girls that we were making before.
Oh my gosh, yes.
No boot up time. It just always works. It's freaking awesome.
Yay. Whoops. Just removed. All right, so that's available on all the places. You can check it out.
Thingiverse, Fusion files, you can edit all of those. You can check out the timeline to see. I have both versions on there, so the way that I saved it, it's at, I think, the non-LC version, but if you just go forward, I think I don't know, 5, what is it called in the timeline, 5 spaces forward, you should get the 5 features forward, you'll get the other versions. All I'm basically doing is closing up that. If you share the
file, I mean, it should have the versions in it, all the saves that you've made.
Yeah, you can see that as well.
People know that, but it's not there.
Yep, so that is all up there, as well as just the STLs if you just want to print these out.
Yep. We also have a 3D model of the PyBadge itself, which you can check out on our GitHub repo.
Yeah.
It's in the description of this video if you're on YouTube. Sweet. All right, that is this week's guide. Very awesome. We'll get some more PyBadges in stock as we make them.
Yes.
Cool. So
next project.
This is Thumbstick. This is the coupon code. So if you want to check out the PyBadge speakers, batteries, all that stuff, cables, you can use coupon code.
Somebody just mentioned that the coupon is not working, so I am logging in right now to make sure.
Yeah, we never did it. Am I live right now? Man. That's so funny.
Let me get your off
code.
Log in. All right, you continue to the next project.
Cool, I got the next project to share then. This one's a fun one. So we got a learn guide on, I think it was last week or so. This is not a lightsaber. This is a light up prop using Adafruit's prop maker Featherwing and an M0 Express. So I'd love to share it with you now. Hopefully it doesn't fall apart like it did over the show and tell. So this is a 3D printed hilt that's designed to not be a lightsaber. It has the feather wing and the feather inside the hilt. We have a slide switch to turn on. This is written in CircuitPython by Kattni Rembor, who's one of the lead software engineers on the CircuitPython team. So one of the things that I asked Kattni to do is it'd be really great if we had varied sound effects. So if instead of just playing the same sound effect over and over again, we can have multiple different sound effects. There's up to 8 sound effects for both things. So we have the swings, and those are different. There's up to 8. And then for harder hits, we have up to 8 clash sounds. So as you're kind of throwing this around, you really get different varied sound effects. So it feels much more like a real item. So one of the main things I wanted to do was to make it easier to reprogram and recharge the battery. So that's what we tried to do here. So if I can get this one. Hey, hello. So here is the pommel, and I made it screw top. So this comes off. And then you have access to the USB port here. This is the feather, and on top of that is the prop maker feather wing, so you can reset and you can reprogram here as well. This has a little pull-out tab, so you can pull this out if you want more space there. So that works out well. And the battery is housed inside here. And now what's interesting about this is that this is all 1 watt RGB. And it's quite challenging to fully illuminate a retractable blade. This is the blade from John Mullet that we did Timelapse Tuesday on. And John did a fantastic job on creating a retractable blade. It's just a series of tubes that are hollowed and put into place. That's really neat. And I designed this to really easily come off.
So just disconnecting this and turning it back on?
Yeah. Hello, hey, what's up everybody? Welcome back. Hello. Okay, sound good. Hello.
Hello.
Yeah,
hello,
it's
hello.
just very static. I don't know whose mic it is though.
Is this one of our mics?
Yes. Turn mine off. Hello, hello. Yeah, it's mic number 1, which is, I believe, yours. Yeah. So if I just mute you, I think we should be okay.
Okay.
Yeah. Hey, what's up, everybody?
Sorry, folks.
Welcome to another live stream. Yeah, I have you off.
Should I just turn the mic off?
Yeah, turn yours off. Go ahead. Turn yours off. Turn your receiver and transmitter off. Turn it back on and see if that helps anything. And then I'll bring you up gradually in the mixer.
All right.
Okay. Hello, hello. Nope, that's you. Yeah.
Interesting.
Yeah, it could be. I don't know.
Continue.
Okay. Well, bring me down a little bit. Okay, so Oh boy, this is difficult. Check out the Learn Guide. We do have this documented as a Learn Guide. This is a little bit different. Reason why the videos are unlisted for various reasons. We are not allowed to publish them yet. We wish they could be published, but they're not published yet. So if you want to get an inside look at them, and you like lightsabers that are not lightsabers, oh, you almost got me there. You can go to the Learn Guide and actually watch these videos. So the things that normally are photographed, wiring, meticulously were recorded as a long 15-minute video. So you can see me soldering or soldering for 15 minutes and assembling this step by step. So I have a transcript here that's basically the voiceover, and this video here, which doesn't show in the editor mode because I'm an admin, I'm editing my own guide. You can play this video. It is unlisted, but you can still watch it. The same goes for the assembly. I'm really happy with the assembly. It took me the original not a lightsaber was very difficult to assemble and disassemble. However, this one is a good exercise in creating a project that has good, decent assembly. So one of the things that's fun that I like is I like to take the blade off. So the blade has this really neat twist feature, and that comes out. And then you can see here that here's the RGB LED. The RGB LED is so freaking bright that you need a lens to focus the light and really show it. So it works well as a flashlight, right? Here's the wall with no lens. And then here's the light with the lens. It might fall out. There you go. So it kind of creates more detail there. This is like a $1 lens that you can get from Amazon, and they're designed to fit right on top of 3-watt LEDs. So there's what it looks like on the inside. And then this piece itself also unscrews. A lot of unscrews here in this design, which I'm a fan of. So this piece comes out, and then this comes off. So the trick here was to figure out how to, because this thing gets really, really hot. That's what they're designed to be. They're not, they don't come with heat sinks, but the bottom of the PCB is aluminum, so it's a little tricky to solder this. You gotta do it pretty quick. So I have these two standoffs. It's hard to see because the coils here cover it, but it hasn't melted yet because the standoffs, they're brass, and they dissipate the heat, and they don't transfer down into this piece where the plastic actually is. So super bright. It gets hot. Eventually, don't touch it, even though I did. And that's kind of it. Yeah. So put that over. Put that there. That just rests on top. And then this cap that has the actual piece here. This just kind of press fits. Well, at least it did press fit. I think I might have fused it in there forever now. Fine with me. So I'll just screw this back on. And that houses that holds the lens in place like that. And then you can put this little cover on top, and that twists as well. So there you go. Really interesting thing is about the speaker. So I'm using the mini oval speaker that we are using in these PyGamer projects. And typically it's mounted to the bottom here of the pommel, but that's where my USB port is. How am I supposed to do that? So what I ended up doing was creating this really cool clip that wraps around this guy here. And I just popped it out, which is really easy to do. It didn't break, and that's where the speaker is. Now, because the speaker is mounted in here, and there's a giant cavity in the hilt, this provides some good acoustics, so it makes it louder. So here's what it is without it. Right? Not as great. And another cool thing about this cavity is I can come in here and disconnect all the JST connectors. So here's the RGB LED, here's the switch, and the speaker as well. So you can come in there and really edit it. This little groove here locks this guy in place because there's a channel that goes along the ring here as well. So I'm really happy about that. And the way it installs is you just kind of fit it in there like this. This is all captured so much better in my 20-minute video. So that just locks in there like that. It has a little bit loose of fit, but it's fine. And you can have fun with it. But not a lightsaber. Yeah, a lot of fun. First time playing with RGB LEDs. So much so that Brent and Kattni had to write an RGB LED library for CircuitPython, which is great. It's awesome. So we got a Learn guide, as we were showing, and check it out. It's got all the parts, all the circuit diagram stuff, all the code as well. This is my favorite prop that we've come out with so far. I wish I could combine the old lightsaber blade with this one and make this super awesome lightsaber.
Strong, yeah.
I'll also say that the lightsabers from Galaxy's Edge have lag in it, and this one doesn't. Ha 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 ha.
Yeah, we
That's
watched
about it.
a ton of videos on it trying to analyze how it looks, and yeah, it might be a nice aesthetic, you know, like having the nice metal castings on there, but when everybody turns it on, they're all so amazed by it, they're not able to see that it's so freaking laggy.
It's
like
delayed.
even when the animation starts up, it's like, oh my god.
Particularly the hits and the swings.
Exactly.
They're just like you hit it, and then like a second happens, and then it triggers the sound effect.
But
this one's instant.
None of the reviewers have actually noticed that. They're all like so amazed
Oh,
by it. Like, oh my god,
at least
the
one
experience.
person. Yeah, it's great. It's a fun thing. So that makes me happy. So yeah, not a lightsaber. It is not a lightsaber. It's a light up prop. Adafruit's prop maker. So check those out. They're in stock right now. They come with the headers and without the headers, so you can save $1 or $2. And coupon code Thumbstick. Yay! Oh my gosh, we did it. Yay!
And then
The audio
real
is
quick,
so fun, isn't it?
Too long didn't read. Bill is asking, is it threads or coils?
There are coils, not threads.
And then what was the failure point when it failed, or when you extended it on show and tell and it fell off? What was the weak point on that?
Yeah, you're right. So I had to redesign the holder, which I just showed, like screwing it off. It had like a twist, a single twist rotation. That's terrible. So I made it double, and it works a lot better now. That was the failure point. Yeah. So yeah, I wouldn't swing it too fast, but
Which you did update the design, so the updated.
yeah, it
package
is.
on
It
there,
is published. Yeah.
Which is how a lot of this stuff happens. We
Oh
update it
gosh!
after,
As soon as it's published, then the
then
real
we
work
can start
starts.
adding and fixing stuff because
Yeah.
we're not in crunch mode, deadline. You
Right.
don't have to release this.
There it goes. So you do have to you have to take it out. The funny thing about the way this works is that you can take off all the pieces individually. They only start to taper once you go down.
At the end.
So yeah, and some folks are having some issues printing. This is definitely challenging to print, this simple tube. It's because it's all shell. It's all perimeter, rather. So it's 2 shells thick, which is super thin. And you're like, well, that's going to shatter as soon as you... And yeah, it does, but you got to be careful with it. We printed it in different colors and did a Timelapse Tuesday on it, which was really fun. Yeah.
Yeah, so we were saying before,
Pretty interesting.
the videos are all unlisted on the guide for this. It'll launch whenever, I don't know if we said what this is launching with, but
No, we didn't.
whenever they decide to release.
Yeah, it's supposed to be a kind of an educational portion. Yeah, we'll see. I don't know. We got a Learn guide, and people can watch it, the videos. Hello. Excellent.
All right, what is next?
We have some Timelapse Tuesdays.
Last Tuesdays. Let me
Yep.
grab one of them. I think the motor.
Sure. The motor. Sweet. So this is an engine that is a multi-part kit that you can download from Thingiverse. And we 3D printed the parts. We assembled it. And Pedro put together a little rig so that we could actuate the motor, the gear, with a continuous rotational servo. And we're powering it all with the Cricut of the Circuit Playground Express. There it is going. So let's look at it for realsies now.
Still goes.
I hope it still goes. Yay.
Okay, there we go.
Sweet.
Yeah, so
So,
it's a simple model that is what everybody in the comments is saying, usually used on airplanes, I believe. And we're just using a little servo on the back that's just actuating this whole little thing here. It's making the rest of the little pistons rotate. So we're just using a Cricut and a Circuit Playground Express on top of that. And I'm just using MakeCode to have it go either negative or positive direction. And that's all it really is. I'm just using the A and B buttons for that. And then the construction of this, which is I think is interesting. Let's see if I can get that to stop. Yeah. Yeah, super easy. It's just popsicle sticks glued on to a piece of plywood. So definitely a really easy way to add like life to like a little model that you might be showing for education or whatnot. So nice little way to animate this.
Yeah, get those parts in motion.
Exactly, yeah. So super cool way to visualize for engineering or whatever. So nice little way to quickly get you going. Nice little Cricut, so Playground Express, and you're off to the races. Pretty cool.
Very cool. Yes, this is a quick one. Very cool. I like how all the pieces fit, and yeah, it's nice. I like the print quality. It's not bad. Yeah, pretty cool. Hot glue for the win. All right, that was designed by a Lens Error, user Lens Error on Thingiverse. You can check it out, and it's a free download. Next one is a belt, a print-in-place belt. I've seen these before, but this one is a nice shape. So let's watch that video. This is 3D printing a belt. So the way this belt is all the hinges are print-in-place, and it wraps itself around in a coil to create a so the length of it can be printed all in one part. You got a tower in the back there purely for just the time lapse itself. People asking like, why are you using the tower? It's so that we can trigger the DSLR. That's why.
Yeah, we're using a slow shutter speed on the DSLR there, and because of that, we have to wait a little bit longer than usual. So the PLA material tends to burn up. So when it gets back over to the part, it doesn't fully detract enough material, and there's always like gaps. So that's why I have that pillar in the back there.
Yeah. Yeah. I don't have anything else to say other than it almost fit. It doesn't really fit me because like I have a waist that's bizarre.
Yeah, I know. Nobody can make like 26 size waists.
It's like, gotta go to like a skeleton shop.
But anyway, if we go over to the overhead, you can see what these the quality of this.
Yeah. Sorry.
Looks like.
Enough of this video.
How they're all held together, and I really like how it prints in a nice little circle here to maximize how much area you have. So this could print on
Length of it,
a small print bed. And then the way that it's attaching are these little hooks on one of the ends. I got these little teeth that just snake in like that, and the little grooves. And it just catches those grooves in there like so.
Yeah.
And it holds on pretty good.
It doesn't pinch you, which is nice.
Yeah. I did have to, because I printed it with a brim, I did have to go in there.
Not sand it, but like kind of.
I used the deburr, deburr to make that nice and not scratchy.
Yeah. It fits in the belt loop. However, if you have like polyester clothes, activewear, it'll probably scratch it up. So stick to cotton or canvas.
Yeah, and came out really good.
Khaki.
I printed this one on the Ultimaker. The
Crusoe one
was way too small for.
It didn't even fit Gavin, huh?
No, it was too big for Gavin.
Yeah. So 6-year-old.
Yeah. And the print quality on this, it looks a little rough only because I'm doing the time lapse for it, which is usually how it goes, because it has to, again, retract, move out of the way, wait for like 10 seconds while the camera does its thing.
All right, so we got some belts. It's from 3D Wash.
Yeah, and he
actually has a couple of
different sizes.
Watch.
Although, like I was saying before, if your waist 28, 27, it's not gonna.
Yeah.
They're all be too big for you.
Yeah, I'm 29. It's just barely is hanging off there, off my bones. Oh, that's a nice one.
Oh, cool.
That's a really nice
I
one.
like the filament they used on that. Whoa, nice
Yeah.
shiny.
Hey, look, everybody, it's Uncle Jesse.
Nice.
Holy moly, everybody printed this.
It's a really good print.
Yeah, that's very, it's very nice. I like the gradient when you change the colors there. Sweet, belts. So we will make a tie next. Oh yeah, the thing, did we not do that one?
Sorry, I didn't set the
Yeah.
beats correctly.
Oh. The coupon codes still don't work, guys. Come on.
26. Set the wrong date on that. Sorry. 27. 6.
Yeah, it took 2 weeks to 3D print. That's why we didn't do the Hangout.
All right, try the coupon code again. It should not say expired again.
Yeah. There was, but I don't have it. The iris.
Yeah, there was an iris one.
I think we gave it to Gavin, and that was the end of it.
And then one last one, really cool one from, I forget his name, Micro Center.
Yeah, this is Andy Lear's design. Shout out to Andy Lear. He came up with a snap fit enclosure for the new Raspberry Pi 4. Did you guys hear about it? There's a new Raspberry Pi 4.
Really? Oh, man.
I completely forgot that was coming out.
I didn't hear about that.
I know.
But awesome little design here. He actually said they used your layer by layers to do the snap fit little, what are they called? Little,
I call them snaps.
the little tabs on here with the little grooves that catch onto the other side of the enclosure down here.
Yep.
Little nubs there, and then using the little standoffs to hold the Pi in place.
Oh, it's a nice
So,
design.
Yeah.
Both hardware and hardware. Hardware and case.
Yeah, so
Yeah,
gotta
Full
grab.
access to it.
Yeah, so we gotta edit this so that it fits our the Cricut hats.
Oh, yeah,
Be a nice
that'd be
little
good.
project for that.
Yeah. Here we
That's
go.
cool.
Sweet.
Probably use this one for the Octoprint case.
Oh, there you go.
Yeah. So if you guys haven't seen, check out the live stream that PT and Lamar did. Runs over all the specs and all that. Even got some really cool demos running on there, so definitely check that out. All new Raspberry Pi 4.
Yeah. What is up with everybody saying like they're proud that they're not going to do anything with it and just put it on the shelf? It's quite bizarre. It's like who else? Like raise your hand if you're not going to do anything with this Pi. And like everybody rose their hand, like 20,000 people. It's like what is going on here?
I mean, at least use it as an Octoprint.
Yeah. So I don't know. People were, yeah. It was like, oh, it'll keep my other Pi company because it's not doing anything either. It's like, what?
I like the response where somebody was like, well, I actually did something with my Pi portal.
Yeah. Yeah, me too. Excellent. Well, that is cool. There's a lot of awesome hardware to play around with.
Forget Thumbstick should work now. Yeah. It gets you 10% off everything in the store except subscriptions and certificates. So definitely don't miss out. Expires at 11:59 p.m. tonight.
Said it. Cool. Later tonight, is that what we're doing? Later tonight, we got Ask an Engineer. It's at 8 p.m. with Lamar and Phil. Shortly before then, it's going to be just the show and tell. Adafruit show and tell. Come in and say hi. 7:30 p.m. Eastern Time is happening tonight. I think we'll be there.
Yep.
Hopefully with better audio.
I like how the audio never fails on show and tell for us anyway.
Well, because it's just one mic. This one has a mixer and then these two wireless mics that we've had for ages. Yep. Cool. Well, appreciate you guys hanging out with us and bearing through the
weekly audio troubles.
Yeah.
We'll figure out one of these.
It's because it's like 2 weeks of no 3D Hangout and it's like double the audio problem in one show. And I apologize we didn't come back as puppets. People were probably upset, like, oh, I thought they were coming back as puppets. We're metaphorically puppets or something. Yeah. We just follow Lamar and Phil blindly. Like, yes. Excellent. Well, thank you guys again. We're going to be in the Discord chat, and I think that's it. Don't forget, John Park is tomorrow. Check out MakeCode Minute. Weekly pick of the week. He's doing picks of the week, which is really cool. His shop talks and stuff. So check it out. We're all hanging out in the Discord chat room. You could chat with us. There are some free stuff going on as well. If you go to adafruit.com/free, you can see all the different tiers. I'm sure they change, but there's always some good stuff to check out. We have same-day deliveries here in the New York City area. We're not here in New York. We're in Florida. But in the New York City area, you can get same-day delivery as an option. We also have a newsletter that happens once a week. This is the new newsletter, so check that out. We have a CircuitPython meeting that happens every Monday at 2 p.m. That is live streamed on the Discord server, so you can check that out. We also have it on the replay as well, on the archive, YouTube channels and beyond. CircuitPython.org, check it out. Easiest way to get CircuitPython on your hardware. Adafruit Daily News, adafruitdaily.com. Check it out if you want to subscribe to daily content. Again, we're in the Discord server. And if you are looking for help, we have a help wanted picture with Adabot. And we have a website that's called jobs.adafruit.com. You can check that out. Make a profile. If you're an employee looking for employees, employer looking for employees, check it out. All right, that's going to be it. This is really cool. Yeah, I could afford to wish to to live near Adafruit as well. I only get to go up like once a year. Sweet. We did it. We're back. We'll be puppets next week.
Don't forget to follow us on our socials for all the behind the scenes that we're working on.
Sure.
And I think that's it.
Yeah. We came in with one mic and we're leaving with,
Came in with 2, leaving with 1.
All right. Bye.
Try to figure this other mic out. See you next week.
All right.
Later tonight.
Later.